Hi. In this set, we have that there are only 4 neighborhoods in a city, L, T, P, and K. And during the onset of a pandemic, the number of new cases of a disease in each of these neighborhoods was recorded over a period of 5 days. On each day, the number of new cases recorded in any of the neighborhoods was either 0, 1, 2, or 3. So the number of cases will be either 0 or 1 or 2 or 3 and no other number apart from these 4 numbers. And then we have these following points known, and we have to figure out which neighborhood has had how many cases on each of the 5 days. So let's make a table for this. We have 5 days and we have 4 neighborhoods, and we need to figure out what is the number of cases in each of these 4 neighborhoods on each of these 5 days. So let's start with the first point. We have there was at least one new case in every neighborhood on day 1. Okay, so on day 1 there was at least one case. That means the number of cases in each of the neighborhoods would be 1 or greater than 1, right? Cool. Now on each of the 5 days there was more new cases in K than in P. So for all of these 5 days, K had more cases than P. Okay, so this number here must be greater than this number, strictly greater than, not even equal to, greater. This number should be greater than this number, right? This number should be greater than this number, and so on. So if this number is 1, this number has to be greater than or equal to 2, correct? If this is minimum 1, if this is 1, this must be at least 2. If this is 2, this must be at least 3. So the minimum value that can be filled here in this box is 2. Okay, so for day 1, the minimum total possible is 1 plus 1 plus 1 plus 2, which is 5. So the total number of cases on day 1 will definitely be greater than or equal to 5. Okay, fine. Coming to next point, the number of new cases in the city in a day kept increasing during the 5-day period. Okay, so the total number of cases in the city on day 2 will definitely be greater than that on day 1. Similarly, total number of cases on day 3 will be greater than day 2, and so on, right? Every day the number of cases is strictly increasing. It's not even constant, it's strictly increasing. And the number of new cases on day 3 was exactly 1 more than that on day 2. Fine. Number of cases on day 3 was 1 more than that on day 2. So if the number of cases on day 2 is, let's say, x, number of cases on day 3 must be x plus 1. Fine. Next point. The maximum number of new cases in a day in P was 2, and this happened only once during the 5-day period. So for P, the highest is 2, and it occurred only once during the 5-day period. Okay, so we'll come back to this point again. Next, K is the only place to have 3 new cases on day 2. Okay, cool. On day 2, K had 3 new cases, and K is the only place to have 3 new cases. That means all other places will have less than or equal to 2 cases on day 2. Okay. Next, the total number of new cases in L, T, P, K over the 5-day period were 12, 12, 5 and 14. So total number of cases in L is 12, in T is 12, in P is 5 and in K is 14. That means the total number of cases during the entire period for the entire city is 12 plus 12, 24 plus 5, 29 plus 14, 43. Right? So the total value of all the numbers that we have to plug in these 5 into 4, 20 blocks should be 43. Okay? Fine. Now let's look at what can be the number of cases on each of these days, day 1, 2, 3, 4 and 5. Okay. So let's start with day 5. For day 5, what is the maximum number of cases that are possible? Maximum number of cases will be when we maximize each of these values, right? So what can be the maximum value for Levmisto? Let's make a case here. So this can be maximum 3, this can be maximum 3. Now this number has to be strictly greater than this. So this value can be maximum 2 and this can be maximum 3. So the maximum value of day 5 total for day 5 is 3 plus 3 6 plus 2 8 plus 3 11. So this value here should be less than or equal to 11. It cannot be more than 11, right? So even if we consider the maximum value of 11, this value cannot be more than 10, correct? So this value will be less than or equal to 10. If you consider the maximum, just the maximum value, this value cannot be more than 9. Similarly, this value not be more than 8, right? So, and if this is 9, this is definitely going to be 8 because the difference between these two values has to be 1. So if we consider the maximum possible case for day 2 to day 5, the total number of cases that you get is 19 plus 19, which is 38. So 43 minus 38 is 5. So on day 1, we will get a total of 5 cases if we consider the maximum case over here. Okay. Now, even if you, let's say, reduce this number by 1, let's say this is 10, this is 11, and this is 8, then this becomes 7. The total on day 2 becomes 7, total on day 3 is 8. If you consider even this case, now what happens is 7 plus 8 is 15, 15 plus 10 is 25, 25 plus 11 is 36. So out of 40, we have 36 cases. So the remaining number of cases is 7. So on day 1, you will have to have 7 cases. But is it possible to have 7 cases on day 1 and 7 cases on day 2? Not possible. Every day the number of cases is strictly increasing, right? So even if you reduce the value of these two, this number becomes equal to day 2's number, which is not possible. And if you reduce the numbers right from here or here, the value here will increase even more, right? For example, if let's say if you let this be 11 and if you make this 9, this can be maximum 8 and this can be maximum 7, correct? So now what happens is 7 plus 8 is 15, 15 plus 9 is how much? 15 plus 9 is 24, 24 plus 11 is 35. So 43 minus 35 is 8. Now what happens? Day 1 is greater than day 2, which is not possible, right? So the only possible case for the total number of cases is 5, 8, 9, 10 and 11. So this total is 5, this total is 8, this is 9, this is 10, this is 11, such that the total number of cases is 43. Okay. So now we had that on day 2, the sum should be greater than or equal to 5 and it comes out to be exactly 5. Exactly 5 is possible when we consider the least number of cases in each of these 4 cities. So this must be exactly 1, this must be exactly 1, this must be exactly 1, this must be exactly 2. So the total here is 5. Coming to day 5, the total of 11 was possible when we considered the maximum possible cases for each of these cities. So this becomes 3, 3, 2 and 3. Okay? Fine. Now, for P, it was given that 2 occurs only once, right? Highest was 2 and it occurs only once. So what would happen is that on the remaining days, the values should definitely be less than 2. For P, 2 has occurred already once, 2, we cannot have another 2. So all the other values should be less than 2. Correct? So now from day 5 to day 4, the number of cases is 1 less. So we have to reduce one of these numbers by exactly 1. And we know definitely we have to reduce Pesmisto, P. This cannot be 2. So the only way you can reduce this number total by 1 is by reducing the number of cases in P by 1. So 2 becomes 1 and the all other 3 numbers remain 3. So from here we get the sum as 10. Okay, fine. Now if you look at Kitmisto, the total is 14 and this is 3. So what is the total that we have so far? 2 plus 3 is 5, 5 plus 6 is 11. So 14 minus 11 is 3. So this number here comes out to be 3. Okay. Now next, if we look at L, so the total for L has to be 12, and the numbers that we know so far is 1 plus 6, 7. So 12 minus 7 is 5. Now how can we get sum of 5 with these 2 days? It can be either 2, 3 or 3, 2, right? But we already know that on day 2, K is the only place having 3 new cases. So no other place will have 3 new cases. So this number must be 2 and this must be 3. And the same logic applies for T as well. So this is 2, this is 3. Okay. And now on day 2, the total number of cases has to be 8. So 2 plus 2 is 4. 4 plus 3 is 7. So this must be 1. And on day 3, the total number of cases has to be 9. So 3 plus 3 is 6 plus 3 is 9. So this must be 0. Okay. So with this, we have completed the table. Now let us look at the questions. First question is, what best can be concluded about the total number of new cases in the city on day 2? Okay. So on day 2, the total number of cases is exactly 8. So this must be option D. Next question, what best can be concluded about new cases in L on day 3? Okay. L on day 3, the total number of cases is exactly 3. So the answer here must be B, exactly 3. Next, on which day or days did P not have any new case? Okay. P not having any new case is only on day 3. So this must be option C, only day 3. Right? Next question, which of the two statements below are necessarily false, is or are necessarily false? First statement, there were 2 new cases in T on day 3. So T on day 3, there were 2 new cases. No, there were actually 3 new cases. So this is false. Fine. Statement B, there were no new cases in P on day 2. So P day 2, there were no new cases. No, there is 1 new case. So this statement is also false. So we have to figure out which of the statements are necessarily false. Both of them are necessarily false. Hence the answer is option C. Both statement A and B are necessarily false. Next, on how many days did L and T have the same number of new cases? L, T should have same new cases. So this is 1 day, 2 day, 3, 4, 5. Basically on each of these days, L and T had same number of new cases. So the answer must be all 5 days. Okay. So that's it for this set. Thank you.